Okay, today I want to talk about section 11.8 power series. I want to talk about the other section, the section 11.9 in the evening, the 7 p.m. today. So now we focus on section 11.8 power series. This is our line. Now I'm going to talk about definition of a power series. Second one, how to check whether a power series converges or diverges. Third one, definition of radius of convergence and interval of convergence. The first one, the definition of a power series. A power series is the summation n equal to 0 to infinity c sub to n times x to the power n. The expanded form is c0, c1x, c2x squared, c3x cubed, and so on. This is like variable x, we can denote it by function f of x. The where x is a variable, the cn is a constant, called the coefficients of the series. Domain of f. The domain of f is the set of all x for which the series converges. Find the domain of f of x equals summation n equal to 0 to infinity x to the power n, the like 1 plus x squared plus x cubed, and so on. How can you find the domain? I want to use geometric series. Summation from n equal to 1 to infinity a times r to the n minus 1, the a plus, ar squared, and so on. We have a conversion result if the absolute value of r is less than 1. And diverges if the absolute value of r is greater than or equal to 1. So let me see. What's that? So this is geometric series, right? The geometric series. What is common ratio R? What's that here? What is R? Do you know what is R of this one? So could you write your answer on the chat room, please? What is R? So what is R of this problem? What's the common ratio R? What do you think? Is X? Yeah, because how can you find the X here? 1 times X is X. How can you find the X squared? Same. Times X is X squared. The times X squared, X is X cubed, and so on. Yes, X is a common ratio. So we have this one, X. So this is a conversion if the absolute value of common ratio is less than 1. So what's that? So this is the same to the x is between minus 1 and 1. So we have this result. Summation n equal to 0 to infinity x to n converges. Converges if x is between minus 1 and 1. So what's like domain here? The set of all x for which the series converges. So what's the domain of this function? The domain is exactly this one. We have open interval minus 1 and 1, like this. This is domain. Like this. What's like the definition of the general one? The more generally, a series of the form summation from n equal to 0 to infinity cn x minus a to the power n c0 plus c1 times x minus a plus c2 x minus a squared c3 x minus a cubed, and so on is called a power series in x minus a, or a power series centered at a, or a power series about a. So we call like this. With one remark, x equals a, what happens? You can plug x equals a into here. So you can plug a into here. This is a, This is A, this is A. So what's that? Exactly C0 plus C1, the A minus A, plus C2, A minus A square, and so on. So what happens? A minus A is going to 0. A minus A square is going to 0, only C0. C0 is finite number. What does it mean? Summation is finite number. What does it mean? The series is convergent, right? Series is convergent. We have like this one. So we have one good result. Series is always convergent at A, right? So we call A the center of the series, right? The series, power series is always convergent at A. It's always true. So this is a problem. For what values of X is a series convergent? Let me see. The power series is also series. How can you check series is convergent or divergent? We learn 7 tests. The test for divergence, the integral test, the direct comparison test, limit comparison test, the alternating series test, ratio test, or root test. We have 7 tests. So what do you think? Which test is the good for this problem? Which method, which test do you want to use? Could you run your answer on the chatting board? Which test do you want to use for solving this series problem? So what kind of test do you want to use? So what do you think? So do you have any idea? Which test do you want to use for solving this problem? Geometric things, yeah, but no, because we have a factorial form, so we cannot use geometric series. So my test is like the best way. Ratio test, yes. We have factorial form or constant to the power form, that we use ratio test, right? We can use ratio test, that we use it. Was it like a ratio test? You can use the like this. Was it like ratio testing? Here we can use this kind of things. Wait a minute, so I can change it a little bit, just slide a little bit, sorry about that. So just to wait, I can change it, slide it a little bit. Here, the slide one, this one, yep. I can change a little bit, sorry, just wait. So here, yep. So the same, here like this, okay, this one, yep, here. The series involves factorials, n factorial, 2n factorial, n factorial squared, or other products including a constant raised to the nth power, c to the power n, c to the power 2n, c to the n squared, something like that we use, yes, ratio tested. Ratio tested. What's like a ratio tested? You can calculate this one, limit of absolute value of an plus 1 over an. N is approaches infinity. How can you do that? What's it like an in this case? The an is this inside one, n factorial times x to the power n. So what's that? This is same to limit. N approaches positive infinity. So you can plug n plus 1 into this n. So we have n plus 1 factorial times x to the n plus 1. over the an is exactly this one, the n factorial x to the power n. This one. This is a limit n approaches infinity. So I wanna expand n plus 1 factorial. N plus 1 factorial is n plus 1 times n factorial. The x to the n plus 1 is x to the power n times only x over n factorial times x to the n. So we have it. So what's like the next step? The next one is use only cross out common factor. Cross out common factor n factorial x to the n. So we have this result. This is a limit. So n approaches infinity. What's that? n plus 1 times just x. So n plus 1 is like always positive, take out. This is a limit. So n plus 1 times absolute value of x. So what's the limit? What do you think? What's the limit? So what is the limit? It's x. So let me see here. Infinity. So depending on x value. So we have two possible answers. So if x equal to 0, you plug 0 into here, 0 times n plus 1 is always 0. The limit of 0 is 0. The 0 is less than 1. We have it. The next one, x is not equal to 0. So x is non-zero. Non-zero number times n plus 1. n plus 1 is going to positive infinity. Infinity times a non-zero number is always infinity, greater than 1. So what does it mean? That we have only one series n equal 0 to infinity. 0 to infinity. N factorial x to the power n is conversion. The conversion, the if only x equal to 0, only 1 point, right? So this is like answer of this question. So like this, like this, so like this. So we have it. The next problem. For what values of x does the series converges? The similar. So the series involves, in this case, x minus 3 to the power n form. We have constant to the power n form. You have to use ratio test. The similar. Limit of an plus 1 over an as n approaches infinity. So same to the next one. So an plus 1 times 1 over n. So what's that? Here, limit n approaches infinity. Was it like an plus 1? You plug n plus 1 into n. So here, so we have x minus 3 to the power n plus 1 over n plus 1 times 1 over an. The 1 over an is the reciprocal of an. Just n over x minus 3 to the power n. One. Next, simplify. n approaches infinity. Top one is exactly the x minus 3 to the power n times x minus 3 over n plus 1 times n over x minus 3 to the power n. So we have it. So what's the next one? So you only cross out common things here. X minus 3 to the power n is cancelled. So we have this result. The result is limit x value approaches infinity. So we have n over n plus 1, is right here. Absolute value of n over n plus 1 times x minus 3. The same. N over n plus 1 is positive number. We can only take out this one. So we have limit n approaches positive infinity, the n over n plus 1 times absolute value of x minus 3. So what's the limit? Could you run your answer on the chatting board? What's the limit? What's that? 0 infinity? Let me see here. This x minus 3 is doesn't change because the n approach infinity, what does it mean? X minus 3 is like a constant. Like a constant. Only take a limit of this one. This one. So you have to take out constant, absolute value of x minus 3, only take a limit. N approach infinity, n over n plus 1, like this. What is, yeah, your answer is 1, you're right. You have to ignore lower terms. You have to ignore lower terms, cross out n. The answer is just this one. Absolute value of x minus 3 times 1, exactly. Absolute value of x minus 3. So when you have a conversion result from the ratio test, this limit value is less than 1. So we have it. So what's that? You have to expand. X minus 3 is between negative 1 and 1. So by using the one property of absolute value sign. So you add 3 to each side. You add 3, you add 3, you add 3. So what's that? The x is between 2 and 4. So the series is conversion of this interval. Is right? This is like the final answer. This is not a final answer. So what happens? X equals 2. You plug 2 into here. The 2 minus 3 is negative 1. Absolute value of minus 1 is 1. Right? The limit value equals 1. What does it mean? The inconclusive. So we don't know. The series is conversion or diversion by using ratio test at end point. What does it mean? You have to use other tests for checking the series is conversion or diversion at end points 2 and 4, only 2 and 4. So here, like this. So we have it. So converges. Note the ratio test is inconclusive when the absolute value of x minus 3 is like equal to 1. What does it mean? Only think about end points, right? End point 2. X equals to 2, you plug 2 into here, the series, summation n equals 1 to infinity, the 2 minus 3 to the power n over n. So we have summation n equal to 1 to infinity, the minus 1 to power n over n. What's that? Summation n equal to 1 to infinity, minus 1 to power n over 1 over n. This series. So my equation. The series is a convergent or divergent. Summation from n equal to 1 to infinity, minus 1 to n times 1 over n. This series is convergent or divergent. What do you think? Could you write your answer on the chatting board? The series is convergent or divergent. So what do you think? So this series is convergent or divergent? What do you think? The series is convergent or divergent? How can you check? This series is like a convergent or divergent? Do you remember? We can use the alternating series test. What's like alternating series test? If the alternating series satisfies two conditions. The first condition, the sequence Bn is decreasing. The another one, limit of Bn equal to 0. The satisfies two conditions. The alternating series is always convergent. So you can check first condition. The sequence Bn. Sequence Bn is 1 over n. What's like 1 over n? We can plug 1, plug 2, plug 3, plug 4. What happens? Less, like this. What does it mean? So sequence 1 over n is decreasing. Satisfies first condition. Second condition, we calculate limit of Bn. Limit of n approaching infinity, the Bn. So we have limit n approaching infinity, 1 over n. What's that? 1 over infinity is exactly 0. So what does it mean? These are two conditions of alternating series test. So what's like the final answer? This alternating series is convergent. Yeah, by using the alternating series test, we have it. This is convergent. So like this, x equals to 4. You can plug the 4 into here. So we have summation n equal to 1 to infinity, the 4 minus 3 to the power n over n. Same to summation from n equal to 1 to infinity, 1 to power n over n. Summation n equal to 1 to infinity, 1 to power n is just 1. Bottom one is n. So what do you think? The summation from n equal to 1 to infinity, 1 over n. So this series is convergent or divergent? What do you think? So could you write your answer on the chatting board? What is your answer? The convergent or divergent? Converges or diverges? What do you think? This one. Do you remember like a P series? You can use P series. What's a P series? The 1 over n to power p, take the summation from n equal to 1 to infinity. This is two possible answers. Converges the if power p is greater than 1. The series is divergent the if the p is less than or equal to 1. In this case, what is p? This is n to power 1 here. The power p is just 1. Just 1. P is equal to 1. Answer is divergent. So we have divergent by using the P series. Like this. Here. So what happens? You can include all convergent result. Converges when the x is 2 to 4. One more. X equals to 2. Yes, converge. Only include only left-hand point 2. So we have this result. Like this. The next example. Find the domain of a Bessel function of order 0 defined by J0x equals summation from n equal to 0 to infinity minus 1 to power n x to the 2n over 2 to the 2n times n factorial squared. So same. So we use ratio test. So same to Lex way. So what's that? This is same to limit n approaches infinity. absolute value of, you can plug n plus 1 into here, n. This one, the minus 1 to power n plus 1, x to the, really be careful, 2 times quantity n plus 1 over 2 to the 2, same, quantity n plus 1 times, here is the n plus 1 factorial squared. Exactly the an plus 1 times the 1 over an is the reciprocal, only flip. We have 2 to the 2n. We have n factorial squared over minus 1 to power n, x to the 2n. So like this. So this is same to limit. N approaches positive infinity. You have to simplify. How can you simplify this kind of things? So like this. The first one, this is absolute value. What does it mean? So always make it positive. You don't need this one. Minus 1 to power n things. You don't need it. The next, you need to expand more. So take absolute value. Here, this one, x to the 2n plus 2. Change it like this, over. bottom distribute 2. So 2 to the 2n plus 2, same. Times n plus 1 factorial is same to what? n plus 1 times n factorial squared. Change it like this. Times 2 to the 2n times n factorial square over x to the 2n. So close this one. So next, was it like this one? Limit. N approaches positive infinity. You have to split. The x to 2n plus 2 is x to the 2n times x squared. This one is same, split 2 to the 2n times 2 squared. What's bottom one? Distribute 2 to the n plus 1 and the n factorial, n plus 1 squared times n factorial squared times the remaining terms, 2 to the 2n, n factorial squared over x to the 2n. So like this. So what's the step? You have to cross out common factors. 2 to the 2n. You have to cross out this one. X to the 2n, cross out. N factorial is crossed out. So we have the remaining terms is like this. Limit n approach infinity. The top one has only x squared. So we have x squared. So we can, the absolute value is here, over. Bottom one, the 2 squared equals 4 times n plus 1 squared. So like this. The power 2 is even power. The 2 is also even power. You don't need absolute value sign. So we have limit. So n approaches infinity. Only x squared over the 4 times n plus 1 squared. Like this. So what's the limit? Could you write your answer? What's the limit? What is the limit? The limit of x squared over the 4 times n plus 1 squared. What is the answer? What's that? The jitter? You're right. The because what's like x squared? X squared is like constant. So n is approaching infinity. The 4 times n plus 1 squared is going to infinity. Constant over infinity is, yes, always 0, always less than 1 for all x. So what does it mean? So we have this result. The Bessel function is a conversion for all x. That's it. This is the idea. Summation n equal 0 to infinity. Minus 1 to power n. X to the power 2n over 2 to the power 2n times n factorial to the power square is conversion for all x values, right? This is like the whole idea for solving this problem. Was like a domain of function j, the domain of j0x is all real numbers, all real numbers. So that's it. This is answer of this question. So like this. Yeah, domain of J0 is all real numbers. The next, the the theorem. From the previous 3 examples, we have this theorem. For given power series, summation from n equal to 0 to infinity, c sub to n times x minus a to the power n. There are only 3 possibilities. The series converges only when x equal to 0. The series converges for all x. Third one, there is a positive number r such that the series converges if absolute value of x minus a is less than r and diverges if absolute value of x minus a is greater than r. Usually we can use the ratio test or root test. What's like radius convergence, integral convergence? Case 1, here, radius convergence is only r equal to 0 because what's the length of one point? The length of one point is just 0. That's right. Here, case 1, series converges only at one point. Length of one point is like 0, so radius is also 0. What's the interval of convergence? 1 point A. Second one, what is the radius of convergence? The radius of convergence is infinity because what's it like for all x? For all x is all real numbers. What's it like interval of all real numbers? Like some the minus infinity to infinity. What's the length of all real number? Length is infinity. Infinity divided by 2 is also infinity. So radius is infinity. So what's it like interval of convergence? All real numbers. The third case, what's the radius convergence? Here, this one, right? This one. So what does it mean? Here, x minus a is where? Between negative r and r. From here, you add r to each side. Sorry, add a each side. X is between negative, a minus r and a plus r. What's like the radius of? We think about this interval from here to here. So what's that? We have left-hand point a minus r. So right-hand point a plus r. Left-hand point is a minus r. What is this whole length? The whole length is left-hand point minus right-hand point. A plus r minus a minus r. So a is cancelled. So we have a plus r minus a plus r is gone. We have only 2r. What does it mean? Length is 2r. What is length of half? The length of half is just r. We call the length, the half of length is we call radius convergence. Exactly R, right? This number, exactly R, this number. What's the interval of convergence? Depending on, we have this interval, A minus R and A plus R. So you can just see there, my second example, we always check series is convergent or divergent at endpoints. The left-hand point included or not. The right-hand point is included or not. We have 4 possibility. Exclude 2 endpoints, only open interval. The only left-hand point is included, half closed interval. Only right-hand point is included, the similarly half closed interval. 2 endpoints are included, we have closed interval. So we have next one. The open interval, the half closed interval here, and closed interval. We have 4 possibilities depending on endpoints. So we are going back to our example. So this is like a first example. We have this result. In this case, what is radius of convergence? Do you know what's the radius convergence? So could you write your answer on the chatting board? What's the radius convergence? So what is your answer? What's the radius convergence? R is, what's that? Yeah, what's R? The 0, infinity, some finite number. What is your answer here? You think about it. So R equal to 0 or infinity or some finite number. What's that? What is your answer? Yeah, answer is 0 because we have only 1 point. The length of 1 point is just 0. Was it like an interval of convergence? Do you know what's the interval of convergence of this case? The interval of convergence is, do you know? Interval of convergence? Interval of convergence is this center, only 1 point here. So like this, so we have it. I will do one more example here. The summation, the n equal 0 to infinity. N factorial like x minus 5 to the power n. You can use ratio test. We have this result. The converges the when x equal to 5. We have this result. So my question is, what is radius of convergence? You know that? What's the radius of convergence? 5 or 0? So really be careful. So only 1 point here, only 1.5. The length of 1 point is 0. Really be careful here. What's that? 0. Always 0. 0, not 5. So 0. So like this. What is interval of convergence? What's interval of convergence? So could you run your answer on the chatting board? Yes, 5. Yes, center 5. You can use cent notation. Yes, so like this. The radius convergence is 0. Interval of convergence is 5. This is like idea. Yep. The next one. The third example converges for all values of x. This is like a third example. What's the radius convergence? Do you know that? What's the radius convergence? So could you run your answer? What's the radius convergence of this example? The radius convergence is, what's that? Do you know radius of convergence? Not 3, but here. The second case, the series converges for all x. What's the radius convergence? Infinity, because the length of all real number is infinity. So we can use this one is infinity because the for all x. What's the interval of convergence? All real numbers. Really be careful. Only 1 point length is 0. The center is convergence. Convergence for all values, the infinity, and all real numbers, like this. Here, in this case, what's the radius convergence? What do you think? The summation x minus 3 to the power n over n converges for x is between 2 and 4. How can you find radius at convergence? Do you know that? How can you find? Negative 3? No, the not center. The not center. Don't use center. We can use converge for this interval. This interval, what does it mean? So we have this interval, the 2 to 4. You need to find whole length. What's the length of this one? 4 minus 2 is only 2. What's the radius? Radius is always the half of length. That's right. Length is 2 divided by 2. So answer is 1. So radius convergence is 1. This is the idea. 1. So what's like an interval of convergence? Here, so this interval. The half closed interval 2 to 4. The one example. Some summation n equal to 1 to infinity. The x minus c to the power n. So this is a. And cn and this is a converges. The converges for x is the 3 and 10. Like this. This is this one. What is radius of convergence? What do you think? What do you answer? What's the radius convergence of this problem? So what do you think? Yes, 7 over 2 is good. Here, 3 to 10. So the length of interval is exactly 10 minus 3 equals 7. The radius is always half, the 7 over 2. What's the interval of convergence? Yes, thank you. Interval of convergence is open interval 3, 10. Yes, it's like idea for finding the radius convergence and interval of convergence. How to find radius convergence, interval convergence? The main idea is ratio test or root test. So here, find the radius of convergence and interval of convergence of the series. Summation from n equal to 0 to infinity, the negative 3 to the power n, x minus 2 to the power n over square root of n plus 1. Here, use ratio test. Here, the like this one is right, because this is same to what? This is same to limit. N approaches positive infinity, the absolute value of an plus 1 times 1 over an. So like this. This is limit n approaching infinity, the absolute value of the what's that? Here, you can plug n plus 1 into this n. We have level 3 to the power n plus 1 times x minus 2 to the power n plus 1 over the square root of n plus 1 plus 1 is right, times the 1 over an. 1 over n is reciprocal, only flip, the root n plus 1 over the negative 3 to the power n, x minus 2 to the power n, so like this. Right? The next, what's like next one? It's like limit. N approaches positive infinity, absolute value of, let me see, this is what? Absolute value sign. Absolute value sign, you just only, anyway, you can just change next one. The negative 3 to the power n times negative 3. The simplify here, x minus 2 to the power n times x minus 2 over the square root of n plus 2 times root n plus 1 over negative 3 to the power n, x minus 2 to the power n, so like this. The next tip, you just only cross out common factors, so like this. So what is this one? This is same to right here is better. Limit n approaches infinity. What is this one? Negative 3 times x minus 2 times the root m plus 1 over root m plus 2. Like this. So what happens? You can take out constant 3, only absolute value sign change positive 3. The limit, the n approaches infinity, the only change 3. The take out constant, this one, the root m plus 1 over root m plus 2. You have to keep x minus 2 in absolute value sign. Like this. So you can take limit. So this absolute value x minus 2 is just constant. When you calculate this one, you have to ignore lower terms. Ignore lower terms. So root n cross out only 3. So we have this result. This is same to only keep 3. The absolute value of x minus 2. So when you have a conversion result, this limit value is less than 1. We have a conversion result. So you have to solve this one. Divided by 3. Absolute value of x minus 2 is less than 1/3. So you just only eliminate absolute value sign. X minus 2 is between negative 1/3 and positive 1/3. That's one. Next, you add it to each side. So minus 1/3 plus 2 is 5/3. This one is x minus 2 plus 2 is just x. The 1/3 plus 2 is 7/3. So we have this one. So this is not a final. So as I said before, you have to check. The original series is conversion or diversion at end points 5/3 and 7/3. That's right. You can keep going like this. You can check x equals 5/3. Only plug into original series. You can plug what happens here. So 5/3 into here. We have it. So this is the same to summation. N equals 0 to infinity. So we have negative 3 to the power n times 5/3 minus 2 is negative 1/3 times the negative 1/3 to the power n over square root of n plus 1. You can combine summation n equals 0 to infinity. The same power n, you can combine two bases, the negative 3 here, the negative 3 times negative 1/3 to the power n over square root of n plus 1. Same to summation. N equals 0 to infinity. So what's that? The negative 3 times minus 1/3 is positive 1 to power n over square root of n plus 1. 1 to power n is just 1. This one. The summation 1 over square root of n plus 1 is conversion or diversion. What do you think? Conversion or diversion? This is conversion. No, you can use P series. Same to what? Summation n equaled 0 to infinity 1 over n plus 1 to power 1 over 2. You can use P series. This is also divergent. So because P equals 1 over 2. The P is 1 over 2 and use P series. P series. So power is 1 over 2 less than y equal to 1, always divergent. Always divergent. So like this. 7 over 3. You plug 7 over 3 into this equation. You can plug the 7 over 3 into here. So we have it. So 7 over 3 times negative 7 over 3 minus 2 is only positive 1/3. So like this. The next combine. What's that? The summation n equaled 0 to infinity. Negative 3 times 1/3 to the power n over the square root of n plus 1. This is 3 is crossed out, just the summation n equaled 0 to infinity minus 1 to power n over square root of n plus 1. So what's that? This is the same to summation n equaled 1 to infinity minus 1 to power n 1 over square root of n plus 1. So this series is convergent or divergent. What do you think? Could you write your answer on the chatting board? So what do you think? This series is like convergent or divergent? Yeah, convergent. So which test do you want to use? The which test? Yeah, alternating series test. So was it like Bn? So here, the Bn is only positive 1 over square root of n plus 1. So here, it's like a Bn. So first condition was like a Bn. The Bn is decreasing, very clear. You plug 1, 2, 3, 4, 5. The first one is root 2. Second term is 1 over root 3, 1 over root 4, and so on. Number is less, like decrease. It's very clear. What's like the second condition? Second condition is take limit of Bn. So n approaches infinity. So limit n approaches infinity, 1 over square root of n plus 1 is 0. So what does it mean? The alternating series that satisfies two conditions. What does it mean? This is converges by using alternating series test, right? So like this. You can combine. Was it like radius convergence and the interval of convergence? Here. Was it radius convergence? Do you know radius convergence? Was it radius convergence? 1 over something, is right? You can use this interval. What is this interval? Exactly. So here, 5/3, 7/3. What's the length? The length is the right in the point 7 over 3 minus 5 over 3. You're right, 1/3. We have 2/3. So we can find only half of 2/3. Half of 2/3 is 2/3 times 1 over 2. Which is crossed out, we have 1/3. Answer is 1/3. So another idea is from here. Same thing, 1/3. So absolute value of x minus center is less than 1/3. This 1/3 is exactly radius convergence. Either is fine. So next, what is interval of convergence? So could you write your answer on the chatting board? What's interval of convergence? Interval of convergence is, so what's that? You're right, thanks. The series diverges at this point. Series converges at this point, only include right in the point, exactly. So have a closed interval closed on the right hand side. The 5/3, 7/3, the closed on the right hand side. Yeah, just like a whole idea for solving this problem. Okay, this is all for today's lecture. Thank you for attending my class. I appreciate. So if you have any question, write your question on the chatting board. If you don't have any question, you can leave a live session, and then we can meet some like 7 p.m. today for remaining section 11.9. Okay, thank you. You're welcome. See you later. Yeah, thanks.